engineering problem on the board. The question says determine the magnitude of the resultant force and its direction theta measured counterclockwise to the positive x-axis. Now, how do we solve a problem like this? First of all, the sole aim of this problem is to tell you how we resolve vectors or solve vectors, whether in 2D or in 3D, and how we make use of this small triangle which tells us the direction. If you don't know that it tells us the direction, now you should take note of it. Now, instead of making use of angles to the x, y, and z axis, you simply make use of smaller triangles. Okay, I think that one is quite interesting. Now, first of all, I'm going to be drawing a plane on the board. Okay, we're having a plane like this, and on the positive y-axis we have a vector which is a force of 20 kilonewtons, and on the right side we have a force F3 which is having a value of 15 kilonewtons. Okay, 15 kilonewtons, and the direction is given by a small triangle 3, 4, and 5. And then for this other vector we're having a force of 15 kilonewtons as well. Okay, 15 kilonewtons, and the direction is given as a smaller triangle. We have 5, 3, and 4. Now, do not make mistakes by solving engineering problems which have direction of vectors given in one side and you mechanically turn it in the opposite direction. Like in this case, do not draw the vector f in this opposite direction because you get a different answer. Now, if I'm resolving this to the x-axis, we'll know that it will be pointing in that direction, meaning that we're going to get a positive value for the f of x of this guy. Okay, now to resolve this vector on the board, I will not make use of the Cartesian form. I just want to do it directly. So to get f of x, or the resultant vector for x, it will be equal to resolving this to the x-axis plus this and plus the other one. Okay, now how do we resolve this to the x-axis? First of all, I'm bringing out the smaller triangle. We're having 3, 4, and 5. The angle here is theta. Okay, first of all, what we want to do is find theta, and theta can be given as a tan inverse of 3/4, or you could make use of cosine or any other value. Okay, but in this case I want to make use of cosine. Okay, if I should make use of cosine of theta, that will be adjacent to our hypotenuse, that is 4/5. Okay, that will be cosine of theta, and then you take the cosine inverse and get theta, then you use to solve. But that is actually time consuming. I will not advise you to solve like that. Rather, I will make use of the numbers given there directly. Now, if I'm resolving to the x-axis for this first 15 kilonewton, we're going to have 15. I'm going to neglect the kilo, and then I'll make use of the kilo. Okay, just to save time and space. So I have 15 cosine of theta, which is the angle between these axes. Okay, plus for this other one, I'm going to call the angle between this x negative x-axis and the vector phi. So I'm going to call the angle phi. I'm going to call this theta. Okay, so in this case we're going to be having the force is 15 kilonewtons. We have 15 kilonewtons too, so we're going to get 15 kilonewtons cosine of phi. Take note, this one is not having negative sign. This is because the vector is in this direction. So when I resolve it, it starts facing that direction, telling you that it is going in the positive x direction. Okay, so from there we can see that cosine of theta from this diagram is 4/5. So we have 15 times 4/5 plus 15. Now cosine in this case of phi is cosine is adjacent to our hypotenuse, that is 4/5. So we're going to say 4/5 as well, 4/5. Okay, and this will be equal to, this gives us that is 12 plus 12 as well, so that will give us 24 kilonewtons. That is for the x-axis. Okay, that is for the x-axis, and we can see that it is positive, so we're going to be having a force in that direction, that is positive x direction. And then for the y-axis, okay, for the y-axis we're going to resolve this guy to the y-axis. That gives us 15 sine of theta. I'm going to be skipping this 15 sine of theta because I've used it before here, so there's no need of stressing. Just use the values direct. Now that sine of theta in this case, the sine of theta in this case, okay, Now from this diagram, sine of theta is 3 over 5, that is opposite over hypotenuse. So instead of writing sine of theta, we'll just write it directly. That will give us 3 over 5. And then we're having a force on the y-axis. You should take note that the reason why we did not make use of this force F2 on this axis is because this guy is only lying on the y-axis. There is no value of this guy when it lies on the x-axis. We can see the value is 0. So neglecting 0, you get the same thing. Okay, 15 times 3 over 5. And then for the other guy, we're having 20 kilonewton directly. No need of resolving, it's already on the positive y-axis. And for this guy, resolving to the axis, you see that it starts facing the negative y-axis. So get a negative value of 15 in bracket, opening the angle, that becomes 3 over 5. 3 over 5, okay? So from there, we can see that these two guys just cancels out. And then we'll be left with 20 kilonewton. From there, we want to get the resultant force. To get the resultant force, we can say that this one is also positive, so it's going in the positive y direction. To get the resultant force, we'll be having a diagram like this. Okay, where we have that as a positive x-axis, and there's a positive y-axis, and this is 20, while this is 24 kilonewton. Okay, so the resultant force is giving us a value r. Let's call this f of r. Okay, applying Pythagoras theorem, we get the resultant force Fr to be the square root of 20 squared plus 24 squared. That will give you a resultant force as, okay, I'll be making use of my calculator this time around to get the value of the resultant force. And the resultant force is given as the square root of 20 squared plus 24 squared. That will give us a value of 31.24 kilonewtons. Okay, that is 31.24 kilonewtons to 2 decimal places. Okay, I'm just leaving it to 2 decimal places. Of course, the question did not ask us how many decimal places, but I just decided to leave it like that. Now, what about the direction? Remember, the question said what would be the direction theta measured counterclockwise from the positive x-axis. Now, when we talk about counterclockwise, you should take note that this is clockwise and this is counterclockwise. Okay, this counterclockwise means we are going in this direction, and clockwise means we are moving in this direction. So if we are to take the clockwise direction, they said from the positive x-axis, this is positive x-axis, so counterclockwise will be from this direction to this point, but clockwise will be from this direction to the vector. So counterclockwise will be the sum of this angle here, this one, and then the angle here. Okay, now to get the total angle here, first of all, we can find the one inside. I'm going to call it beta or alpha in this case. To find the angle, make use of tan. We know that tan of alpha is opposite of adjacent. Opposite in this case is 20 over 24, and alpha becomes the tan inverse of 20 over 24. So the tan inverse of 20 divided by 24 gives us the value of 39.8 degrees. Okay, alpha becomes 39.8 degrees. That's the value of alpha to the positive x-axis in the clockwise direction. Okay, so I'm going to put in brackets, this is clockwise direction. Okay, or rather, since the question said from the positive axis we are taking the counterclockwise direction, it means if we are going like this from the positive x-axis, we are having the clockwise direction, and if we are going like this, we have the counterclockwise direction. Since they said from the positive x-axis, not from the force, they said from the positive x-axis, we can leave 39.8 degrees as the direction for this particular question. But if the question said otherwise, that is, it said from the resultant vector to the positive x-axis, not from the positive x-axis, we're going to be taking the sum of the angles from this direction to this guy. That will be same as 360 minus 39.8 degrees. So our final answer is 31.24 kilonewtons in the direction of 39.8 degrees. Okay, so the sole aim of this video, like I said initially, is to understand how we can find result vectors when we are given direction in terms of these smaller triangles, so in which we find in problems on 2D and 3D vectors. Okay, in our future examples or future videos, I will be solving more examples. And if you have a question on this video or a video you'd like us to talk about, please do it to make it in the comment section. My name is Dr. Flash. Exquisite tutorial, always got you covered. See you in the next video.
Hi, You wish to blast your JAMB exam with an amazing score of 300 plus. Then say no more cause Exquisite Tutorials got you covered with their JAMB Rema classes, which will be coming up from the 15th of this month till 25th. It will be comprising of 6 hours daily intensive classes, which will be divided into afternoon and evening sessions. And also, there will be likely jam questions drills and past questions review. And also, they'll be revealing to you shortcuts to all calculations in physics, chemistry, and maths. All this for a price of just 5,000 naira. But the amazing things about this is that they are giving a discount of 3,000 naira for the first 20 persons. So hurry up now to take off your slots.